I don't wanna see you while you fall apart. Even though you told me to get back your heart, I still spin inside your orbit. Yeah. You say that I should probably start to walk away. I'm hoping that you stop and make me have to stay, 'cause I'm floating in your orbit. apart. Even though you told me to get back your heart, still spinning inside your orbit. I should probably start to walk away. I'm hoping that you still make me have to stay, 'cause I'm floating in your orbit. Pull me back, take my hand, call my name. You understand, I wanna stay, 'cause I don't wanna walk away. Yeah, I'm stuck in your space. I lost my luck, put me away. You understand, there's nothing left to say. Pull me back, take my hand, I wanna name. You understand, I wanna stay, 'cause I don't wanna walk away. 'Cause I don't wanna walk away. Pull me back, take my hand, call my name. You understand, I wanna stay, 'cause I don't wanna walk away. Cause I don't wanna walk away. Cause I don't wanna walk away.
All right, hello everyone. It is Friday here, so we are going to do some binary exploitation practice, continuing on with the nightmare course. I unfortunately had to miss yesterday's stream. This week has been kind of low in terms of my attempt at daily streaming, but yeah, I was working on a real difficult problem and just needed to get it done. Not a hacking problem, but just a coding thing that I've been working on, a different project off stream, and finally managed to get it all sorted out pretty late last night, but that ended up going all the way through my time that I would have been streaming. So unfortunately, we've missed all of the x86 instruction decoder stuff this week and had very little of the hacking stuff. So I'm going to try to do some binary exploitation today, make sure that I don't lose my edge or whatever from practicing it regularly. And on the weekend we're still going to do the try hack me stuff, but then we'll get back into like the normal schedule next week as much as I possibly can. I think a lot of my projects are wrapping up, so I should have fewer distractions that might keep me from streaming on any given day. All right, so we're just going to get into it. We're still in the ROP section. This is the last of what I think are the stack pivot. Yeah. So hopefully we can get through this last stack pivot challenge, and then we're into the SROP section, which is really interesting because I was looking around at some other stuff. I wasn't specifically looking for SROP stuff. I was looking at this language security workshop, which is related, sort of connected with the whole idea of the weird machines, and has been sort of started by this Sergey Bratis guy who I think coined the term weird machines and has really like done a lot of the initial work around, or been involved at least. I don't want to like put it all on one person's shoulders, because certainly this paper about it maybe has him listed first, but we've got 5 people total on the paper. So I don't want to like, reduce the. I don't want to say it's all him, right? But I think he's been a significant factor in all of this, and he's sort of like also involved in running or organizing these language security workshops and doing the reviews of the papers. And there's one that just sounded real interesting. They're talking about portable shellcode, and it turns out this is about SROP. And weirdly, well, I guess it's not weird. What is weird to me is this. Oh, that explains it. Okay. Because I was like, I thought SROP wasn't that new, and this was the second to most recent one, I thought. But I probably just clicked on the wrong link. Not necessarily the wrong link, but yeah. So I thought, for some reason, I wasn't really looking at the numbers, and I thought this was the most recent workshop other than the one that was going on this year, which may have actually happened. I don't know. It was supposed to happen in May, and with COVID and all that, I don't know. But I guess this was maybe the first one then. So that was actually the paper at which SROP was originally described, which I thought was pretty interesting, or at least it was interesting how they were phrasing it in terms of a generic shellcode. Because, a lot of my experience with shellcode, with ROP chains and all of that, is that it's rather, you're basically assembly coding, and so the assembly code that works is going to be dependent on the platform that you're running on. Obviously, it's always going to be dependent on the actual machine ISA that is supported. So I don't think you could, I guess in like a broad sense, if you find where the right signal calling related stuff, I haven't actually read enough about SROP to know quite how it works, but presumably you are returning to some code that sends a signal, and that signal, when it's handled by the application, achieves some impact that you were looking to achieve, but maybe you couldn't just achieve that directly with ROP code or something. I'll have to read this paper or maybe some shorter explanation of it to get a sense for how it works before we get into that section. But I guess technically the way that signal stuff is handled is going to be more OS dependent than machine dependent. So assuming you can get, a return address. Oh, okay. So it's a SIG return oriented programming. So like you are maybe jumping to a SIG return instruction, which I think is a particular instruction. SIGRET, maybe? I want to do this. Maybe it's just a function that's defined by the OS, but I think there's a particular instruction that is necessary in order to be able to return from a signal handling state, and because it's like, or maybe that's an interrupt return thing. I don't remember now. So I'll have to look at that as well. But yeah, I thought it was a weird coincidence, but it turns out this is from 2014, so that really has been around as long as I thought it had been. But I guess it's nice to be able to see the paper that sort of spawned that idea. I don't know how often these things get used in practice in the real world, but would certainly be interesting to find out that that stuff. So, and I think honestly, a lot of these papers in the language sec workshops are quite interesting to me. I don't think I'd ever really go to one of these conferences. It does feel fairly academic oriented, and I'm not really tied into any of that stuff, but I can at least read the papers. And so, I mean, there's just a lot of ones where the titles seem interesting. Like this certainly is automatically curious to me. This idea, weird machines aren't that weird, we are. And maybe, it has my brain going like, oh, is it the idea that like the sort of, if you were to try to characterize the state space or the possible combinations of execution flow through any given program that is vulnerable in such a way that makes it how we would term it a weird machine, the vast majority of the actual ways in which that program could work are in the category that we would define as like a weird state, where it is being programmed by the input rather than treating the input as we had intended. And so then we're the weird ones for having this very selective way in which the program is intended to execute this. Even though our intended execution might characterize a vast number of possible states, if you think about any meaningful application, there's going to be such a huge state space explosion, so to speak. We wouldn't really have a good, meaningful way of characterizing or relating to the actual number of potential states, even though it is, I think, by definition, a finite number. It's just, quintillions of quintillions of quintillions of quintillions of just numbers that are impossible to imagine. Millions and millions of digits or something if they were in decimal, or I don't know. And so even though those, what we intend the program to do might still be characterized by that number, there might be an even larger number of all the ways in which it could operate that we didn't intend, and thus we are still the weird ones, perhaps. But it might, have a completely different meaning. But certainly that name is just sort of like intriguing to me, and I probably should watch this video. Not on the stream, obviously. Y'all can watch it on your own. I guess I can put it in chat in case anybody is watching this on the VOD and wants to see that. It's called Language Sec 2020. I guess you can't search for it. But if you go to langsec.org, langsec.org, you can search your way through to the 2020 papers or the 2020 conference page, and then click on papers and slides, and it's the second to last entry. And just check out all the other stuff as well, I think. So okay, that's enough of unrelated stuff. But yeah, we will be getting into the SROP stuff in the next section. And then RET2 CSU. I feel like I have seen these already. I think last time I was sort of looking forward to all the stuff that is in the ROP section, I was confused by this one. I was like, I don't know what RET2 CSU is. I'll figure it out when I get there. Now that I've gone through some of these previous ones where we had to write entries into the Finney array so that they would be whatever code we wanted to execute would be called on the program exit process. I believe that was called CSU Finney array or something. I think the CSU is related to that process. It's both for the init side and the Finney side, and the finish, so to speak, side. So probably something about putting data into there. But I would be curious to find out what CSU stands for, like C standard U. Now I'm just like, let's look for libc CSU init. Because is that like just the name that is defined by glibc, and maybe other libc implementations call it something else? That would make sense to me. It's not a name that needs to be known by any of the actual C code. So let's see. It lives in CSU/libc, or libc start rather. Is there any explanation of what CSU stands for, though? Common startup, or just C startup, I guess. Okay, startup. I was not thinking about startup being maybe two separate letters. So I could see that being what that's about. Just do like libc CSU. Yeah, not Colorado State University. I don't know. I'm gonna go with C startup, but it also does the reverse, the finishing code as well. I mean, it's interrelated concepts, so that makes sense. Okay, so if we return to that, we're probably returning to the exit stuff because the init stuff is already finished. And then ret to system, one would think that involves returning to the system function, but I'm also a little confused because it's the last portion in here, and if you can just return to the system function, that's either much easier or there has to be some other complication involved. So I don't know, we'll find out when we get there. For now, we've got XCTF 2016 B Overflow. So I'm just going to go with, that's a buffer overflow that they're referencing there. Okay, so we don't need a flag file, I guess. I don't know, we'll figure it out as we go if we need to generate a flag file. There was not one in the Nightmare Course directory for it, so usually they have one if a flag file is necessary. It's a 32-bit ELF binary. It is dynamically linked and not stripped, so that's helpful. And what do we have from LDD? It is just libc linked, and check security says I need to update, and interesting. So this one is, I think they're just getting into like, you maybe need to do some kind of stack pivot to take advantage of the vulnerability in here. But if NX is disabled, you shouldn't need to do ROP, right? We've got read-write executable segments, so maybe we have to do some kind of stack pivoting to enable us to write to one of those segments that is writable executable. And then we can maybe overwrite the return pointer to jump to it or something. So like, I can see it being something that you put into the stack pivoting section, but I would think if we're in a position to do ROP, we would also in this case be in a position to just do shellcode. So we might be headed back to the days of this buffer overflow, stack buffer overflow section, which was a bit more straightforward, although I haven't done a like direct shellcode in a while, but shouldn't be too much trouble to get back on that route. No PIE, that's handy. So, we know addresses, not stack addresses, presumably, but yeah, I guess that's the question, right? Are we writing to the stack? Yeah, maybe we could do a partial override or something. I don't know. We'll find out. And all right, let's open it up with R2. Let's just, and let's just run it once. Okay. So, well, one interesting thing, we get the period after an end line. Can we overflow a buffer? Is that what we're looking at? Does that make sense to me? Yeah, so it's seg faults and then, okay. Oh, so it reads in something, not with gets, probably. It probably calls read, because I think it read my new line, which I had to enter in order to get the input in. Whereas in this case, it read only this much before deciding to put the period. And then it seg faulted, probably because even this much is too big for the buffer, so it's still reading too much. Even though it is bounded, it's a bounded read, presumably, because it didn't read the whole thing. Or I guess any kind of read call has to have a length. But if that length is longer than the buffer that you're trying to read into, you can still overflow, and in this case cause a seg fault. Maybe we try to jump to, yeah, so we try to jump to somewhere within this portion. I don't know where, right? But I mean, we could go back to the good old days. Okay, well, don't be like that. I'm trying to remember how we had, because I tried to use this the last time. I did generate a De Bruyne pattern, right? But then I couldn't get it to give me the thing. Let's just take this string and do Python okay, and we do want it like raw or something, or yeah, there we go. So this will be our input. Come on. All right, I'll just have to enter the A myself. All right, and then we can look at where we got to and see if we can simply throw this in. Yeah, see, it gives me -1. Okay, so in this case, little endian found it at 36. So, okay, maybe I was just like missing the 0x the last time I tried it. So if we do Does that work? We got, why did it do that? Oh, and I need to, okay. Oh, I'm missing the open paren. What? Getting messed up by the terminal. Okay, so then, oops. Yeah, okay, cool. We get control over the pointer at that moment. So, is it going to write this? Well, it must be writing it into the stack, otherwise we wouldn't be overflowing the return pointer. But we don't know where the stack is, so can we... I see, that's probably why it's a ROP, because we can do like a single, maybe a single stack pivot. Kind of thing, and then we'll have to find out what our gadgets are, I guess. We probably don't have a lot because it's dynamically linked. But if we can return to a pop RSP, something of that nature, or ESP in this case is 32-bit. So we can control where the stack points, and I don't know if we're going to have an RIP modifying. Oh, well, we could push a stack address, and then return, basically. So that's the kind of like what we were doing on some of the previous stack pivots were like pop into stack pointer and return. So we would return to whatever address was at the top, at the location that we had just, the address that we had just popped into stack pointer. We would read that address and then return to there. Which was probably, then we needed to know an address to go to. And in this case, we don't, like, it would be most helpful if we could simply return to the location of the stack pointer. So if we pushed the stack pointer itself and then returned, or we added to the stack pointer and then pushed it, or pushed RBP maybe with some modification. Either of those would allow us to jump somewhere onto the stack, but then we gotta like be concerned about where on the stack we are trying to go to. So I think we're gonna need to actually dig into this with radar. All right, so it does. So we basically align the stack 16-bit, and then, or 16-byte rather, and then we just move into this vol function for presumably vulnerable. Prints out the stuff, and then does fgetS. Okay, which I think also takes a length. I think that's what the 32 hex is for 50 bytes. Let's see. So yeah, it takes the pointer for the buffer to read into, presumably, and the size, and then the file stream. So we are moving standard in into the third parameter, 50 into the second parameter, and this address, which is ESP minus, no, sorry, it's EBP minus 20. So local 20H is EBP minus 20, meaning 20 hex rather. And we're going to read 32 hex. So after 20 hex, we will be at the location where we've pushed EBP. So that's another 4. And then the next 4. So 24 hex, which is 36. That's why we could get away with doing a 36 right, and then the next 4 were the first return address. So that means we have 10 additional bytes. No. Got 24 hex. Sorry, it's yeah, it's 14. Right? Yeah. So we have 14 bytes that we can write. I don't know. Presumably we're not going to use the additional 2, but we can write 3 gadgets into the ROP chain. So we could maybe find a gadget that modifies ESP sufficiently to I guess we don't want to modify ESP, but we could maybe modify EBP and then push it in return. Let's see what our gadgets are. Okay, so and then we can subtract 24 hex from ESP. We probably, yeah, well, that's a weird one to have before a return. Usually you add the ESP before the return. But we do have this one. It's actually the same one as here. So it pushes EBP, moves EBP, or moves ESP into EBP, and then subtracts from ESP, and then immediately returns for some reason. I wonder what that function is. Can we just 48 for FD? That's the hint function. Okay, so maybe that's just them giving us the gadgets we need, the gadgets we crave. Okay, so with a subtract ESP24 hex, we are at, so we're going to be at EBP plus 4. Yeah, so EBP plus 4, which we've already done leave by the time we do our ret. So when we leave, we are going to first move EBP into ESP, and then we are going to pop into EBP. So ESP had what EBP had, plus 4, right? So subtract 24 from that. Is that really just the beginning of our buffer? I guess, because if it had EBP plus 4 is what ESP will have when we get to the return. What the value of EBP has in this stack frame, because by the time we get to the ret, the EBP actually will be something else, but that doesn't matter. ESP will be what EBP plus 4 had been, and then we're going to subtract 24 hex from that. So EBP plus 4 minus 24 hex is the same as EBP minus 20 hex, which is the start of our buffer. So we just need that one gadget, and we can jump to the beginning of our shellcode, to the beginning of our buffer, which will have our shellcode. So they made this as straightforward as possible within the context of still technically using a little bit of ROP. So I think we can just go for it. Let's see. This is where I start to forget what I haven't done actual shellcode in a minute or two. Let's just go here. I'm going to leave this one open because I so often need to refer to the receive stuff. But I do want make sure that I'm remembering. So yeah, we can just call pwn.asm and pass in some stuff. It'll use our context, and maybe we need to set that context. Arch equals i386 maybe, and context dot ls equals Linux. Let's double check on the context. Could probably have just clicked it here. And then we need shellcraft dot i386, and we're gonna do .sh. Where's the okay? Is this not where you can find the linux.sh? Of course, yeah. Okay, so we are just going to call shellcraft.i386.linux.sh, and then payload is equal to shellcode. Payload plus equals a times len payload minus, sorry, 36 minus that dot encode, and then payload plus equals stack pivot, and we'll have to get the stack pivot because I didn't actually copy that. Okay, so that, and we of course need this P32. Yep. Okay. Then what was the input? Question mark, new line, I think. Or did I? Yeah, it's a new line on there. What are the chances that this will work? You know what, let's do it as a NOP sled first, just in case my math is wrong for some reason, but it seems like it would line up properly. So payload is going to be plus equal to shellcode. Payload starts as 36 minus len shellcode. Cool. Times 36 minus. Yeah, I think so. What? Do I? Oh, okay. Why? How long is our shellcode? Oops. Okay, fine. We're not going to use shellcraft. We're going to write our own shellcode if we can remember what is involved. Well, you know, let's go ahead and exit, or let's print out the original shellcraft stuff. So that we can probably just remove some bits that turns out we wouldn't necessarily need. Yeah, I can leave it indented, I guess. That's fine. So yeah, we do need to push /bin/sh. That is fine. I know on this system we can kind of get by with maybe not doing this part where we push stuff. So let's see. Why do we push 4 and pop it into? Yeah, I don't really care about that. Oh, and we do need something like sub ESP. Do I want to do sub? Wait. We are subtracting 24. Oh, I'm probably thinking about this wrong as well. So we're subtracting 24 hex from ESP and then returning, which means that we also need to push ESP. Yeah, I need to remember that. So let's see, do we have a way to control ESP actually? Or are we just writing a ROP chain in this buffer and the fact that we can execute on the stack doesn't mean anything? Because that's kind of annoying. But it looks like that is probably the case. Yeah, because we would need like a pop ESP. We have no such thing. Ugh. Okay, do we have enough gadgets to do the ROP chain for our stuff? Because there isn't anything that moves into ESP either. So, kind of sad on that front. Let's see. Grep, pop. Oops. Okay, we can pop EBP, EBX, EDI, ESI, although these are chained together. That's probably fine. Can we not pop EAX? Oof. I mean, we might be able to use this one. We would need to pop a value into EDX, which we don't have a way to pop into EDX, it looks like. Great. Okay. Right. Yeah. But maybe we can move something into EDX. It's getting a little bit more annoying. The limitation that we have in terms of gadgets. I don't know why I mean, this is a failing that I often have, is I've got like a sort of wishful thinking aspect to how I'm going about this. So I saw the like, oh, we could go back to here, and I remembered, oh, NX is disabled, so like we just need to get ourselves returning to the stack. But wait, do we have a Meowcat? Hey, how's it going, man? No, we don't have so we can push EVP, of course. Watching, trying to. Are you referring to me as the best? I don't know about that. I don't know if you're still in the chat, but thanks for the follow, Kiko 103. Appreciate it. You know, I try, but I don't know about. I would say there's definitely a lot of people better than me. So we can't push very much at all. We can push segment registers. I don't think that helps anything. And yeah, we can push EBP, but of course, the thing that we have pushed from EBP, and we would of course need to have already moved stack pointer into there or something, done something meaningful with it to get the right value into EBP. But that gadget continues onwards and says now we're gonna overwrite EBP with ESP. That's fine, we've already pushed it. But then we modify ESP. That's the subtract 24 hex that we're already using. So we aren't getting access to the EVP value that we just pushed. And that is like the only register push gadget that we have access to. So we are quite limited. We could try a libc info leak, but of course we could do a libc info leak and then jump back to the beginning of the vol function. So why don't we do that, and then we can write our gadgets as we need to, or even just use the one gadget or something. Okay, take a different approach. But as I was saying earlier, I feel like I quickly get into this mindset of like assuming that maybe something is easier than it seems like it should be. Because I saw that like NX is disabled and just was like, all right, I guess there's going to be some way to execute stuff on the stack, but it's not. I mean, if we get far enough that we have the ability to do that, we can do other simpler stuff at this point, because we still need to be going through ROP in the first place. Yeah. So we'll get the libc file. We're going to try an info leak. And the way that we are going to do that is, or let's just do like libs. So we're going to say proc dot, let's do a ROP chain, is going to be we need a pop RDI, or a pop EDI rather, which we have. It is going to pop also EBP, and I think that is fine. I think we can handle that. So we'll just need to throw, ooh, that does get a little trickier though, because we've only got 3 bytes. So we will need to do the stack pivot first. That'll pivot our stack into our buffer, where we can put the ROP chain to begin with. Or like, we basically need one gadget at the end, not the one gadget thing, but a single gadget for the ret that will pivot us back to the beginning of our buffer, where we can have the other gadgets. Because if we need to pop 2 values, in fact, like the info, the libc, like leaking the puts address and stuff, is minimum for element ROP chain, I think, because you need the pop into the EDI, RDI register, whichever, depending on your bit, your 64-bit, 32-bit, whatever. Then you need the address of puts in the global offset table, and then you need the address of puts in the PLT table, and then you need the address for the next gadget, basically. So minimum of 4, and we only have space for 3. Technically we have space for 3 and an additional 2 bytes to partially overwrite whatever the next value is, but I guess we could leak that. We could probably achieve it in a single thing, but we could also just use the stack pivot to go back to the beginning of our buffer, and then we've got as much as we need. So yeah, let's do that. We'll have this function in a minute. Okay, so for this ROP chain, we still need pop EDI, we need puts GOT, puts PLT, and then we'll do main. And we'll just say run ROP with ROP chain. Okay, so then for this one, we are actually going to start with the receive. So we need to run that, and then we need to say okay, so we need to go until the period character. So yeah, proc.receive until period, and then receive until /n, drop equals true. We don't want the /n on there. And then we want to return p32 of libc raw plus b0 times 4 minus len libc raw. So we will pad it out with null bytes at the end, and then convert that to 32-bit integer. That'll be our libc base. So we can say libc base, or like call this get libc base, let's say. And then we can print it out. Okay, then how to actually run the ROP chain is we want to construct a payload that is equal to, let's just start it this way, we'll do it in the most imperative way possible. For entry in chain, payload plus equals p32 of entry, and then payload plus equals a times, you know what? I want to just use double quotes everywhere. That's technically the intended style for Python. A times 36 minus len of the existing payload, whatever that size is based on the ROP chain that we're doing, and payload plus equals the stack pivot gadget, and then we want to proc.send payload, and we can go ahead and pass the receive until period in this side because we want to do that every time anyways. I think it don't matter. Yeah. Okay, so I think this should leak us libc base, and then we'll go interactive. That's fine. Oh, because we don't have the gadget set up, of course. Pop EDI does require us to have the 2, so I'll need to fix that. And this one was sub ESP24 ret. Okay, so this one is some like EBP. Okay, so our pop EDI also pops EBP. So first we pop into EDI, the puts GOT entry, then we pop this junk into EBP, and then we're going to return to puts PLT. which will eventually return us to main, and that should be good enough. But we need to also get let's do puts. GOT is binary.got puts PLT is binary.plt puts. And main is binary.symbols main. Let's just not. Oh, that lines up weirdly nice. Okay. I think that is all the things we need now, and we'll get the one gadget or whatever we'll figure out once we have the libc base going. Oh, I need payload encode. Thank you. And stack pivot. P32 of stack pivot. What is going on? Why did it not? So we were going to receive until period, but we didn't get the period. What do we get instead? We get nothing. Weird. And then we're trying to receive until new line. So do we need to say send line? I don't think we should need to say send line. Okay. Unit tail when send one. We got a seg fault at 804A01D. Which is nothing. Okay. So why does this payload not work? We've got that address, we've got the next address value are 1, 2, 3, 4 ones, and the next address, final address, and then padding. That all seems fine. But if we don't provide, well, we're just gonna have to debug it in GDB. I don't actually care about that at this point. All right. So we want to break on the return. We don't get to the return. We are still in the read call, so it does need new line, which is weird because I thought our payload sending before was long enough. How many bytes is this? If we that is 36 bytes. And then presumably following that is our oh, we need to send 50 bytes, I guess, maybe. And then if we don't send a new line. Okay. Okay. So let's see if that actually gets to the return. It does. So we go to our sub ESP24 and then we return, which is, where's the stack right now? We are missing the, we're off by 1. Okay. I guess because there's the ret from the gadget itself. Okay, fine. That'll work. So let's do whatever. 4 bytes of C's to begin with, and we'll just skip those. All right. Okay, so now we return to pop EDI. Yeah, we pop the address of the puts PLT entry, or GOT entry rather, into EDI, and then we pop the junk into EBP, and then we return to the PLT, which goes into the puts function. And gets to what is going on with this situation. Why is it comparing? Am I misremembering the calling convention? Just always go to Wikipedia for this for some reason. But I would think, oh, right, because it's x86, we just need to push the, my bad. Okay. Okay, fine. I'm thinking in I don't think we need push EDI. I think we can I need to keep track of where it is going to be looking for. So if the stack pointer is pointing at this value when we return to puts, then it is going to look, it's going to assume, I think, that this was the return pointer. Is that accurate? Let's just do it and then we'll figure out where it is looking at. But that's why EAX is getting AAA in it, because somewhere in the code for puts, it's moving the parameter, first parameter, into EAX. And the problem is that was taken from the portion of our payload that was beyond the drop chain itself, because I filled that space with A's. So we need to move the actual first parameter to later on in our ROP chain section. Maybe put some junk before it is my thinking, but I don't think I've spaced it properly. We'll just have to run it in GDB and figure out what the spacing needs to be. Okay, so I'm going to do that, subtract, and now we are at the puts PLT entry with junk here, and then the address of the GOT entry afterwards. So I guess one possibility is that this stuff from EBP is what got into EAX, because we just pushed EBP and somehow EBP had been, oh, well, not somehow, but through the fact that that was in our buffer overflow portion before the return address for the stack pivot gadget. So it's possible that this ends up being treated like that, but I think it's one of these A's, more likely. So I guess what we can do is just keep walking through it. Until EAX has the value okay. We're filling up a lot of registers with, yeah. Okay. Well, that's not what we care about for EAX. Need something else to move into EAX. So this one is EDX plus 68. That's just going to be something related to the standard in IO file pointer thing or whatever. So now EDX plus 46, don't care about that. EDX plus EAX times 1 plus 94. No, that wasn't it. I don't know all what it is doing, to be honest. Maybe this is the wrong way to go about it. Maybe I should put De Bruyne sequence stuff in those gaps, and then we could see from the actual value in EAX what the position was that it was moved from. But such is life. I am not doing it right now. Required argument is not an integer. What? Oh, that's from some other thing. Okay, so, and this was from, oh, I need U32. Okay, let's see what it looks like. Did we get a print from that? Unpack requires a buffer of 4 bytes. How is it not 4 bytes? It is whatever we got back from libc raw, which we can just print, because I guess why not? Oh, okay. We got a bunch of stuff. I see. So we should be able to do okay, that seems, oh, and that's not the base really. And that seems wrong because it's not the base. We want to return puts adder minus libc puts. Right. Okay, that seems a lot more likely to be a real address. Okay, so let's go with one gadget. Oof, not what I need. I think I actually need to hand copy that, maybe. One gadget, that address. Hey, we got a lot of options. We could figure out the GOT address and move it into ESI and then null out EAX or push. Okay, so yeah, let's look at our other gadgets. And we can definitely find these gadgets in libc, I guess. Do I want to do that? Let's just see if we can find them in in the main binary. I laughed a little bit because the only reason to do it that way rather than find them from libc where they're guaranteed to exist is that running ROP gadget on libc is going to generate a lot of output, and I don't want to deal with that at the moment. So let's look at like pop. What can we pop? We can pop EBP. We can pop EBX. So we could pop GOT address of libc into EBX. That's fine. And then we can, maybe can we XOR EAX? Let's look just for EAX stuff. The deck and the move one would be nice to achieve what I'm thinking about, but I don't think that is possible for our purposes. Yeah, maybe we gotta use some gadgets from libc. There's too much like confounding stuff. The deck one would be nice, but then we do ADC, add with carry of capital A into AL, and that's gonna leave it not being null, unless we had a way to move a value into, like a specific value into it. But if we had that, we could have just moved null into it in the first place. So, and all of these, well, there are the options where ESP just has to be null, which I guess we could do. That's actually pretty straightforward. So we could pop EBX and then return to this gadget, which will, the return will pop, and then if the next value is null, so let's give that a shot. Oh, the address that, yeah, that's fine. Okay. EBP equals libc.got and ESP equals null. Or it was EBX, right? EBX for this one, yeah. So this is actually, and then we need a pop EBX. Okay, I think we can achieve that. We can just say run ROP and actually just pass the chain here with, let's see, what is the first thing we need? Pop. Oh, and I wonder if, we should still GDB this current thing, because it shouldn't segfault. It should actually take us back to main. And it didn't seem like it was doing that. So I've probably still got a problem in this rock chain that I need to sort out. But since I'm already in the headspace of working on the actual shell rock chain, I am going to just work on that for now. So we got pop EBX, and we need libc GOT, and then we need one gadget and just a null. Okay, then how do we get the actual base of GOT? Can we just get the first entry? Let's do like print libc.got. See what that says. Okay, so this is 254.72. It is hard to see if all of these are actually like this is in order, right? 2932, 2936, 2940, 44. There's a skip here for some reason to 52, but this is 54, 25, 47, 2 versus 32, 932. So a big jump there. So I don't understand how to treat this in terms of its presence within the GOT, and like maybe this is the first entry in the GOT. So we look at symbols and then grep for GOT. Of course it's going to be all on one line. And yeah, like what is this a, okay, I see. Can we just do like, all right, so is there maybe a GOT start or something? It doesn't seem like it. So hacktricks.xyz. Is that all of them? Okay. I said something about one gadget. Using one gadget. Right. But does it say anything about how you find GOT entry? Yeah, that's an interesting one. You could just try to overwrite the GOT with the one gadget rather than trying to get the libc leak. So again, it's like, how do you know the GOT address? There's another. Is this just a fork? Yeah. Is this the same thing? Looks like it. Yeah. Well, I can just attempt to guess that it is this value, that libc stack end is the lowest addressed location in this. What is it? D. Okay, so yep, that seems like it is the lowest address. So they were sorted. There is just some gaps in there. That's fine. Okay, but I think whatever this is not in the GOT. It's my guess, because it's so far off. Lowercase c, lowercase p as well. Not len. Hex of this number, which is not a string. Okay. Guess I can throw it in there, or I could actually just select libc stack end. Equals libc dot got of that. And all right, let's oops. step through it because, again, I think we're getting the seg fault because I think my first RUP chain is not working. So we'll get into puts. Can we do finish on that? Okay, so we've got a seg fault on 0101. Interesting. Oh, right, because that 0101 is the address, the return address, as I said, and yeah. So this is where we are returning to, and when we start on, so it'll pop that in point to here when puts starts, and it'll start with this as the return address, and the first parameter being the thing immediately prior to the return address, higher up in memory addresses and prior on the stack, basically. Okay, cool. Then now we got a syntax error. Okay, still seg faulting, but you know, stuff to figure out for sure. Let's see. Is there anything simpler here? I mean, maybe we can just write one of these as null. Then we got to be able to pop ESI. Wow. And we could, but we have 3 pops from that. It's kind of annoying, but we can do it if we need to pop ESI instead of using one of these. Oh, but these still require GOT address, so that's still, yeah, I mean, maybe we just set up the call to system as necessary, I guess, and then let's go that route and just not even worry about the whole situation. Okay, so for that we're going to use, let's see, one gadget. We're going to say ROP gadget. No, we're going to use string. I think it was. Cool. So that's the address of our string offset in libc. Oh, you know what? There's so I think that pop. No, that one is a standard one, but we didn't add the libc base to the things that were from libc. So that maybe, you know, doesn't help anything. Why do we have libc? Oh, right, we have libc puts for the calculation purposes. Okay. Well, let's see what happens if we run it. Still seg faults. Okay. So I'm gonna just not bother with this stuff. We're gonna do libc system, and we're gonna have main as the return address, and then this guy is libc base plus that. Okay, so then And libc system also needs to be libc base plus that. Damn. Okay. Well, let's see how it works when we do it in GDB. Maybe we're not even getting to that ROP chain still. I thought I fixed it, but you know, we'll have to see. Did we get to the breakpoint again? Yeah, we got to our breakpoint. So ESP, why is it broken like that? Oh, maybe we don't want to go back to main. We want to go back to the call to vol, maybe? If that simplifies things, because I think the issue is yeah, let's try that. I think that's the most reasonable for maintaining. So we'll just do main plus 6. Maintaining our stack situation, because at this point the return is pointing into our buffer. It's offset a little bit. So I'm assuming that's the issue. And like maybe the one gadget stuff would have worked, but I've already sort of gotten past that. Right, still doesn't work. Okay, so ESP still pointing. Which is weird. We'll set the breakpoint at the beginning of vol. Oh, we need to just continue until we get that. Okay, we'll continue. So that takes us back to the beginning of vol, where our stack is it is kind of what it is at this point. Still got a bunch of our stuff from the previous one, but that's fine. It's got the address for us coming back into main because we went to the call site, and so then it did the call, and that's fine. Then this one is from us because I believe this is the puts GOT address, and then all of this is for sure from our payload. So we're just gonna continue through, and we'll do the puts whatever. Don't really care about that. And then we have our fgets. So what does this do to the stack situation? We have CCC is the beginning value. Where is our... So we put in EBP minus 20. Is that accurate? Yeah. So let's see what that looks like as EW, I think, for word for 4-byte from here. So yeah, why do we have A's and stuff? Because we just wrote into EBP minus 20. Oh, because I didn't minus the 20. Although that is, yeah, we got the, still off by 1, which is very confusing. I think it is because I must be writing one too many characters on the previous. So then when it reads again, it reads another, like the final character from our previous input. Yeah, that was it. Sweet. Well, I feel pretty good about this one. I don't think I had any, I mean, other than at the beginning where I really convinced myself for some reason that because there were like no restrictions configured that we were going to do executing stuff on the shell. It was all pretty much like reusing the skills that we had applied in earlier ROP challenges, getting a leak because we have, well, in theory, we had just enough space. I think we probably really could have fit it in those additional, well, we probably couldn't because those last 2 bytes, so we had a total of 14 bytes of ROP chain space, so to speak, where the first 4 bytes are overriding the return pointer for the vol function. So that means we could fit 3 4-byte ROP chain elements, and then we've got another 2 bytes left over. And like in theory, if that memory location had an address that was, you know, somewhere else in the binary or something, we could overwrite the lower byte or lower 2 bytes of that. But the issue is with FCATs, we are doing a string read, so it's going to null terminate the buffer. So if we read the 49 bytes in, and that was part of why I had the like, oh, I wrote too many bytes and we were off by 1 in this section. If we read in 49 bytes, it's actually going to write 50 bytes into the buffer, and the last one is always going to be a null byte because it's always going to add the null terminator. So unless it worked out that your partial override of that 4th entry in the ROP chain would allow a null byte in either the low byte or the second to lowest byte, then you're not really, it's not going to work out basically. And I think that's probably not a very safe bet. So rather than try to use those 3 gadgets, we made use of a stack pivot to get back into our buffer, get the stack pointing into our buffer, because they had conveniently provided us one that it subtracts the correct amount to go to 4 bytes into our buffer. And so then we could put our ROP chain in the buffer, which is much larger. We could do basically as big a chain as we needed for this purpose, at least. I mean, you wouldn't be able to do 20 entries in that ROP chain or something, but it's very rare that you need a ROP chain that long because you can get to the heart of the matter very quickly, I guess. And there was certainly some wasted time trying to get the 1 gadget stuff to work when really we could just call system since we can find the address of bin/sh. I don't know why I use 1 gadget quite as much as I do. If we aren't restricted to a single gadget for some reason, then it's probably just a lot more straightforward to throw in a 3 gadget chain. In the case of 32-bit, where you just need to have it on the stack. So you write system, then you write whatever you want the return address from system to be, which doesn't really matter, and then you write the parameter to system, which should be the address of the bin sh string or whatever you need to run, assuming you can find that address in memory. So that's pretty good to have. 3 gadgets is not too bad. Certainly fit in the space that we had available. In fact, with those 3 gadgets, we didn't even really need to do the stack pivot for the second time, but I had already written code to do that, so it doesn't really matter. And for 64-bit, you would probably need a minimum of, I guess you could do a minimum of 3 gadgets. If you're doing the system call, you can pop the address of /bin/sh into RDI. If you have a gadget that just does pop RDI ret, then you can get away with the 2 elements for that, and then the 1 element for the system address that you were returning to. So basically the same length minimum for both of them. Yeah, it's more guaranteed that you could get that minimum situation with 64-bit, because you really just need the address of system. Like you're not actually employing any gadgets beyond call system, ret to system, basically here, this kind of thing or whatever, right? And then you're just setting up the stack as necessary. You need a spacer for whatever the return address would be, and then you need the 4 bytes for the pointer to the string you want to pass to system. Okay, so let's just real quick go through the walkthrough here, and then I think I'm going to call it a day. It's a little shorter than most of the streams, but this has been kind of a low energy, low participation week for me already anyways, and I think I'm just going to try to focus on coming back fresh for the Try Hack Me stuff tomorrow. And doubly so, like, I don't know enough about SROP to think that I'm going to make any decent progress starting on Fun Signals. Is that Fun Signals or Fun Signals? It makes me wonder. Yeah, Signals. Okay, they just have a typo in the menu, in the table of contents or whatever. I guess it could be sigils, but spelled slightly wrong. In any case, yeah, so I think I'll just finish up the README, just browsing through it to see how they went about it, and oh, they have a jumpy. See, now this is a thing that I hadn't considered. So they must have gone about their ROP chain approach somewhat differently than I did. So yeah, this will actually have some interesting aspects to it, I suppose. And then what am I saying? Yeah, tomorrow we'll do the Try Hack Me stuff, and we'll see if we can make. I think we've got one more room in the current section of the offensive pen testing path, and then we're on to the final section, which maybe has one thing, and then that I don't know if I know how to do it or whatever, and then 2 of them are like, more introductory around buffer overflow stuff, I think. So those should be, I've said it many times at this point, so it's like I'm really getting ready to jinx myself, but I feel like I've done enough practice on that side of things, on the binary exploitation stuff, that like a challenge that is intended for people who haven't ever done it shouldn't be a terribly difficult thing. But we'll find out. And hopefully we can get through all of that tomorrow and Sunday, and then next time I go back to try Hack Me, we'll have to figure out some more stuff to do, graduate to some more difficult boxes, I guess, even though, gonna be honest, my experience with it when things got even a little bit difficult where they weren't giving me a walkthrough, had, serious frustrations involved. But at the same time, it feels a little better when you actually manage to get those ones done rather than finishing the ones where they told you everything to do in the first place. Okay, so yeah, they actually did use the fact that you've got NX disabled. So they didn't have to bother with the ROP stuff. They got their shellcode all figured, like they were able to run their shellcode because they did a thing that I didn't think about at all. I've never done, in fact, I used the command option that turned off seeing this kind of gadget, which is a habit that I got into for no good reason other than I looked at all the options for the ROP gadget tool and saw like, oh, there's a thing to turn off this JOP thing, and I wasn't working on any kind of challenge that required JOP, and I didn't really necessarily know how I would make use of it. But in this case, it probably, there's a possibility at least that I would have seen that gadget and realized the value of it, which is, oh, we can just go to whatever ESP is. So we could have done our sub ESP ret and then done a jump to ESP, which would have then put our IP at our buffer. And so then we are running our buffer and we can just throw shellcode in there because NX is disabled, and we can just start with something that modifies ESP so that if we do any pushes or whatever, not overriding our own shellcode, but that's fine. I've done all that stuff before. So could have made this simpler for sure. Stack pivot gadget will move the stack pointer down to our own input. It will leave off by executing the first D word of our input as a return pointer. That instruction pointer will be, oh, right. So we would need like 4 bytes of junk, 4 bytes for the jump ESP gadget, which is interesting, but it's gonna, I guess, yeah, with the ret, then ESP will point to the thing following this gadget address. So then we can just have our shellcode immediately after that, and we're jumping to it. Cool. 4 bytes of input. We'll store our shellcode there, which will be executed by the jump. Yeah. So okay. So a thing to try anytime I happen to have a binary which has NX disabled but does not have a leak of stack address or just doesn't have a stack address leak, we could at least look for something to maybe jump to ESP, and maybe there's some other gadgets to get ESP to where we want it to be, and then just run shellcode through that. So then they go through that process. Yeah, so the shellcode is right after the jump ESP gadget, and when you finish the jump, then you are executing your shellcode and just throw it in there. Needs to be relatively short though, like our shellcraft stuff was too long anyways, but we could use this very short thing, for example, 23 bytes. Yeah, so short enough to fit in there even with the 4 or 8 bytes of prefix that we need. That would be a total of 31 bytes, and you got 36 to work with. So cool. That all, is reasonable. They did a much more straightforward, simpler solution, I guess, to what I ended up doing. But again, there's different ways to get into it, right? And I feel okay with using the ROP approach that I did. So there you have it. Thanks to everybody that was watching the stream. Appreciate it. And we'll be back tomorrow with Try Hack Me. Have a good day, everybody.